students. Now these formulas are very important. Previously we have discussed some different types of formulas according to basic definition of the Laplace transform. Now this is the table. Very important formulas. While solving the problems, these formulas are very important, and they are not asking proofs of the formulas. By using these formulas we can solve the problems very easily. Now once again, Laplace transform of f of t equal to integral 0 to infinity e power minus st f of t dt equals to f bar of s. Means the question, every time the question in terms of t, when you are applying Laplace transform, then according to that formula we get the answer in terms of s. Means finally you have to understand the question in terms of t and answer in terms of s. Now this is the definition of the Laplace transform. Now Laplace transform of 1, Laplace transform of constant 1. Now this is the L is nothing but Laplace operator. Now Laplace transform of 1 equal to 1 by s. In the same way, Laplace transform of k equal to k by s. This is another formula. This is Laplace transform of 1 is 1 by s, Laplace transform of k equal to k by s. Now Laplace transform of e power at equal to 1 by s minus a. Laplace transform of e power minus at, that is 1 by s plus a. Observe these two functions. E power at means 1 by s minus a, e power minus at means 1 by s plus a. These two things you have to remember. And Laplace transform of sin at equal to a by s square plus a square. Laplace transform of cos at equal to s by s square plus a square. Now Laplace transform of sin hat equal to a by s square minus a square. This is hyperbolic function. Laplace transform of sin hat a by s square minus a square. Laplace transform of cos hat equal to s by s square minus a square. This is, these four are trigonometrical ratios. Laplace transform of these trigonometrical ratios we have given the formulas. Now observe this one. In these four formulas, sin at, cos at without hyperbolic function, the denominator is s square plus a square. That you have to remember. And hyperbolic function sin hat and cos hat, then observe the denominator s square minus a square. Means sin at, cos at we are getting the denominator s square plus a square. For sin hat and cos hat, s square minus a square. And moreover, cos at, for cos things we are in place of numerator we are getting s. Observe this one. This is s. For sin hat we are getting constant. The coefficient of t here, the coefficient of t is a. In sin hat also the coefficient of t is a. That's why we are getting a. For sin hat we are getting sin hat and sin at, in place of numerator we are getting a. And for cos at and cos hat we are getting s in place of numerator. These are the very important observations. By these observations we can remember the formulas very easily. The next formula, Laplace transform of t equal to 1 by s square. Now this is formula. Laplace transform of t square equal to 2 factorial by s cube. Laplace transform of t cube equal to 3 factorial by s power 4. T 1 by s square. For t square 2 factorial by s cube. For t cube 3 factorial by s power 4. In the same way, by observation of all these things, Laplace transform of t power n equal to n factorial by s power n plus 1. S power n plus 1. Now this is the formula, and we are writing another formula also. N factorial is nothing but gamma n plus 1 divided by s power n plus 1. Then this formula is useful when t power n is there here. if n is in terms of fraction, then the second formula is very useful. This gamma n plus 1 by s power n plus 1. This is very useful. By using this formula, when do you have power of t is in terms of fraction, means p by q form, t power 1 by 2, t power 3 by 2, then this is useful, gamma n plus 1 by s power n plus 1. That formula we will use it. Next, this gamma already we got here, that's why I am explaining here this gamma function. This gamma function is also important while solving the, I am not explaining that total chapter gamma function, just few definitions. Gamma n definition is integral 0 to infinity e power minus x, x power n minus 1 into dx. This is the definition of gamma n. Now observe this one, x power n minus 1 is there, here e power minus x is there, and the limits are 0 to infinity. This is improper integral. When in place of limits, if you got infinity or minus infinity, then that is nothing but improper integral. Now we are writing here gamma n, and one more formula, gamma n plus 1 equal to n factorial. Gamma n plus 1 equal to n factorial. This you have to remember. Suppose gamma 5 is there. Gamma 5 can be written as gamma 4 plus 1, means 4 factorial, like that. And this gamma n plus 1 we can write it as gamma n plus 1 equal to n gamma n. This is also. These three formulas are very useful while solving the problem. Now once again, gamma n plus 1 equal to n factorial, and gamma n plus 1 equal to n into gamma n. And while solving the problem, these constants, gamma of some constants are important, fraction parts. Gamma half equal to square root of pi. This is standard value. This you have to remember. While solving the problem, we can write directly. Gamma 3 by 2 is square root of pi by 2. Gamma 5 by 2 equal to 3 root pi by 4. 3 root pi by 4. Now gamma 3 by 2 is nothing but, gamma 3 by 2 can be written as gamma n plus 1. Gamma n plus 1 means gamma 3 by 2 plus, how do you write this gamma 3 by 2? Gamma half plus 1 means half into gamma half is square root of pi. That's why we are writing here gamma 3 by 2 equal to square root of pi by 2. Next, gamma 5 by 2. Otherwise, if it is difficult, you have to remember these much values. Definitely, it will be useful while solving the problem. Gamma 5 by 2 equal to 3 root pi by 4. And gamma minus half equal to minus 2 root pi. Gamma minus half equal to minus 2 root pi. And gamma minus 3 by 2 equal to 4 root pi by 3. Gamma minus 5 by 2 equal to minus 18 by 5 square root of pi. These values are important. Frequently we will get this type of values. Suppose if they asked you gamma minus 7 by 2, by using the formula gamma n plus 1 equal to n gamma n, we can calculate very easily by using that one. And we have special chapter on beta and gamma function. Using that you can see that chapter, you can verify.